everyone. So for today, we will be discussing how to solve problems involving ideal gas equation. This lesson will help us understand how gases behave when pressure, volume, temperature, or the amount of gas changes. Unsa day ang ideal gas equation? The ideal gas equation is one of the most important formulas in chemistry and physics. So, ang ideal gas equation ko no is kanang usa siya ka-importante nga formula sa subject nga chemistry and physics. It combines all the simple gas laws into one relationship written as PV equals nRT, where the P stands for pressure, V kay volume, N is number of moles, R is the gas constant, T is temperature in Kelvin. Kani nga equation, if nagpakita nga if usa sa ilaha nga mag-change, it means the others will also be affected. So, we can rearrange the equation depending on what we need to solve. For example, to find the number of moles, we have the N equals to PV over RT. To find the volume, V equals nRT over P. And to find the pressure, P equals to nRT over V. To find the temperature, T equals PV over nR. So basically, kanay nga usa ka formula, makasolve siya sa everything about gases as long as we know the correct values. So, now, before solving, we must choose the correct value of the gas constant, the R. What is the value of R? So, unsa ang value sa R? The value of R nagdepende sa unit nga gigamit sa pressure and volume. The common values of R kay if ang pressure is nasa sa ATM and the volume is in liters, 0.08206 liters ang dapat gamiton. So, if the pressure is in pascals and volume is in cubic meters, 8.314 joules ang gamiton. 62.36 liters when pressure is in torr and volume is in liters. 8.257 times 10 raised to the power of negative 2 liters when pressure is in bar and volume is in liters. It is very important to match your units with R. Otherwise, your answers will come out wrong. So, for our first problem, we have to calculate the temperature. So, ang una na to nga problem is atong kuhaon ang temperature. I-calculate na to. So, what is the temperature in Kelvin at which 0.654 moles of neon gas occupies 12.30 liters at 1.95 atmospheres of pressure? So, ang mga given nga gipakita gihatag is mao ni siya. And ang formula nga dapat na itong gamiton since ato mang kuhaon, ato mang i-calculate ang temperature is kaning T equals to PV over nR. And para ma-solve din nato siya, atong i-substitute ang mga given ngadto sa kaniang gamiton na itong equation. Ato siya i-substitute and atong i-solve. So, mao ni siya ang final nga answer, which is the 447 Kelvin. So, this means that at 447 K, the gas molecules is moving fast enough to produce the pressure and occupy the volume. For our second problem is pangitaon na to ang volume. So, a balloon contains 0.10 moles of helium gas at 200,000 pascals and a temperature of 300 K. What is the volume of the balloon? So, unsa kuno ang volume sa balloon? So, ang given nga gipanghatag is mao ni siya. And since ang ato ang pressure is in pascals, ang atong gamiton kay ang kaning 8.314 joules. And ang formula nga atong gamiton or ang dapat natong gamiton is the V equals to nRT over pressure. Kay ang ato man kuanon kay ang volume man ang atong i-calculate. So next is substitute ang given sa ngadto sa mga equation yan na. And here's the final answer. So after solving, we get V equals 0.00125 meters cubic meters. Since the 1 cubic meters is equals to 1,000 liters, this is equal to 1.25 liters. So the balloon's volume is 1.25 liters. This means at the pressure, the gas expands to fill about 1.25 liters. So next, for our third problem, let's move on and finding the pressure. A 5-liter container holds 2 moles of gas at 25 degrees Celsius. What is the pressure of the gas in atmospheres or the ATM? So, since degree Celsius man ang gihatag nga given sa temperature, we have to calculate that into Kelvin. So, the given are N equals to 2 mole, V is 5 liters, T 25 degrees Celsius, R is 0.08206 since ang atong pressure is in ATM. So, first, the equation that we'll be using is P equals nRT over V. But akong giingon ganina nga ang 25 degrees Celsius is to convert convert na to into Kelvin. We have to add. So the final temperature is 298.15 Kelvin. And next is substitute the given and solve. So this is the final answer, 9.97 atm. So the pressure of the gas is almost 10 times the atmospheric on Earth. That's how tightly the gas particles are compressed inside the container. So for our last problem, let's solve for the number of molecules. So how many moles of gas are in a 5.0 liters container at 2.0 atm pressure and a temperature of 27 degrees Celsius? So ang temperature na is degrees Celsius gihapon ang gihatag, so we have to convert that into Kelvin. The given are this. Yeah. And the formula that we will be using is N equals PV over RT. And then substitute. We get the 0.406 mole. So there are 0.406 moles of gas inside a container. That's a little less than half a mole. So to summarize my report, the ideal gas equation connects 4 important variables of gas: the pressure, volume, temperature, and moles. When solving, number 1, always convert the Celsius into Kelvin. Number 2 is use the correct value of R. And 3, and last, rearrange the equation depending on what is asked. That's all. Thank you.